Welcome to the channel of Advanced Mathematics to learn topic of algebra. In this topic of algebra, I will cover subtopic number 3 on logarithm. I divided this subtopic into 6 parts. Part A will explain short history of logarithm. Part B will explain meaning of logarithm. Meaning of logarithm. Part C will explain types of logarithm. Part D will explain law of logarithm. Part E will explain graphs of logarithm. Part F will explain application of logarithm in real life. Okay, let me begin with part A, short history of logarithm. Logarithm was first invented by Scottish mathematician John Napier. So, John Napier was the first person to publish discovery of logarithm in 1614. John Napier is well known as the father of logarithm. He coined logarithm from two ancient Greek terms, logos and arithmos. Logos means ratio and arithmos means number. He used the first 3 letters of logos and the first 6 letters of arithmos to coin word logarithm. Word logarithm represents ratio number. And the main objective of Naperian or natural logarithm in 1614 was used to simplify mathematical calculation. And in 1616 up to 1617, in 1616 up to 1617, an English mathematician known as Henry Briggs visited John Napier. Although John Napier died 4 April 1617, but his effort made Henry Briggs to publish his invention of common or Briggian logarithm in 1624. Okay, let me conclude on a short history of logarithm. Logarithm was defined by John Napier as proportion of numbers. Logarithm was defined by John Napier is proportion of numbers, but currently logarithm is defined by mathematician as a way of expressing exponents. Okay, let me continue with part B, meaning of logarithm. What is logarithm? Part B, meaning of logarithm. What is logarithm? Logarithm is power or exponent or index to which a fixed number known as base must be raised in order to produce a given number. In this definition of logarithm, there are three basic terminologies. First terminology is power or exponent or index, and I let this terminology as P. And the second terminology is fixed number, as well known as base, and I let this second terminology as B. And the third terminology is given number, and I let this third terminology as A. In subtopic number 2 on exponent, we see these three terminologies are relating as given number A is equal to base B raised to the power of P. How about in logarithm? First, we write logarithm as log. I used first three letters of a word logos. And usually we write given number here. As well, usually we write base here. So, what does this expression means? Log of A to base B means how many times base must multiply by itself in order to produce a given number A. And the number of times for a base to multiply by itself in order to produce a given number A is equal to power. So, when base is raised to the power P, then we produce a given number A. This path means base raised to the power of P. From these two equation 1 and equation 2, you can see there is a special relationship between equation 1 and equation 2. And equation 1 is exponent and equation 2 is logarithm. Logarithm is opposed to exponent and exponent is opposed to logarithm. Okay, let's see conditions for logarithm to be equivalent to exponent and the exponent to be equivalent to logarithm. For log of a given number a to base b is equal to power p to be equivalent to exponent given number a is equal to base raised to the power of p, it must meet the following conditions. First condition, base must be greater than 0. This is true for all positive number greater than 0 except base equal to 1. And base for all positive numbers, base is not equal to 1. As well, given number a is greater than 0. Okay. In order to understand the meaning of logarithm, let's look at the following examples. Example number 1. Example 1. Convert the following into exponents. Roman 1, log of 81 to base 3 is equal to 4. Roman 2, log of 16 to base 4 is equal to 2. Solution. Roman 1, log of 81 to base 3 is equal to 4 is equivalent to exponent first. 81 is a given number, 3 is base, and 4 is power. So this logarithm is equivalent to exponent first. 81 is a given number which is equal to base 3 raised to the power of 4. This is how log of 81 to base 3 is equal to 4 is equivalent to exponent 81 is equal to 3 raised to the power of 4. Okay, let's look at Roman 2. Roman 2 is log of 16 to base 4 is equal to 2. This logarithm is equivalent to exponent first. 16 is a given number, 4 is base, and 2 is power. So this logarithm is equivalent to exponent given number is 16 is equal to base is 4 raised to the power of 2. Okay, let's look at example number 2. Example number 2, to convert exponents into logarithm. Example number 2, convert the following into logarithm. Roman 1, 3 raised to the power of 2 is equal to 9. Roman 2. 125 is equal to 5 raised to the power of 3. Solution. Roman 1. 3 raised to the power of 2 is equal to 9. Here, 9 is given number, 3 is base, and 2 is power. So this exponent is equivalent to a logarithm log of a given number, which is 9, to base 3 is equal to power, which is 2. Okay, let's look at Roman 2. Roman 2 is 125 is equal to 5 raised to the power of 3. 125 is a given number, 5 is base, and 3 is power. So this exponent is equivalent to logarithm log of a given number, which is 125, to base 5 is equal to power, which is 3. Okay, let's look at example number 3. Example number 3 is to find the value of x. Example number 3, find the value of x. Roman 1, log of x to base 9 is equal to 2. Roman 2, log of 81 to base x is equal to 4. Roman 3, log of 125 to base 5 is equal to x. Solution. Roman 1, log of x to base 9 is equal to 2. In order to find the value of x, first we must write this logarithm to its equivalent exponent. This logarithm is equivalent to exponent given number is x, base is 9, and the power is 2. This is the same as 9 times 9, which is 81. So the value of x is 81. Okay, let's look at Roman 2. Roman 2 is log of 81 to base x is equal to 4. In order to find the value of x, we must write this logarithm to its equivalent exponent. This logarithm is equivalent to exponent given number is 81 is equal to base is x raised to the power of 4. In order to find the value of x, we must write 81 in terms of power 4. 81 is equal to 3 times 3 times 3 times 3. In right hand side, we have x raised to the power of 4. According to product rule of exponent, when we multiply two or more numbers with the same base, then we add their exponent. Here there is 1, 1, 1, 1. In left hand side we have 3 raised to the power of 4, and in right hand side we have x raised to the power of 4. As long powers are equal, then base are equal. Therefore, the value of x is 3. Okay, let's look at Roman 3. Roman 3 is log of 125 to base 5 is equal to x. This means how many times 5 must multiply by itself in order to produce 125. And the number of times for 5 to multiply by itself to produce the number 125 is equal to the value of x. In other way, first we must write this logarithm to its equivalent exponent. This logarithm is equivalent to given number is 125 is equal to base is 5 raised to the power of x. In order to find the value of x, we must write 125 in terms of base 5, which means 5 times 5 times 5 is equal to 5 raised to the power of x. According to product rule of exponent, when we multiply two or more numbers with the same base, then we add the exponents. Here there is 1, 1, 1. In left hand side, we have 5 raised to the power of 3. And in right hand side, we have 5 raised to the power of x. As long bases are equal, then powers are equal. Therefore, x is equal to 3. Okay, let me continue with part C. Part C is types of logarithm. Types of logarithm is determined by its base. Part C. Types of logarithm. Types of logarithm is determined by its base. And for logarithm to be equivalent to exponent, its base must be greater than 0, except for base equal to 1. So base is greater than 0 and base is not equal to 1. So there are many types of logarithm, but in mathematics and other field of science, there are two most useful types of logarithm, which are common logarithm, and the second most useful type of logarithm is natural logarithm. Okay, let me start with first most useful type of logarithm, which is common logarithm. Common logarithm first type of logarithm is common logarithm, as well known as Briggshian logarithm. This was invented by an English mathematician, Henry Briggs, in 1624. Common logarithm is logarithm to base 10. For example, Roman 1. Example of common logarithm is log of 1000 to base 10, which is equal to 3. This log of 1000 to base 10 is equal to 3. You can write it as well as log of 1000 is equal to 3 without writing base 10. This is common feature for common logarithm. As well, you can write log of 100 is equal to 2. This is the same as to write log of 100 to base 10 is equal to 2. This is a special feature for common logarithm. You can write base 10 or you can't write base 10, but anyone who see log of 100 is equal to 2, he knows this is common logarithm. Okay, let's see second most useful type of logarithm, which is natural logarithm, as well known as Naperian logarithm. It was named after John Napier. Second type of logarithm is natural or Naperian logarithm. What is natural or Naperian logarithm? This is logarithm to base e. E is a Euler constant whose value is approximately to 2.71828. Okay, let's see some examples of natural logarithm. Example, log of 9 to base e is equal to 2.19722. As well, you can write log of 9 to base e is equal to 2.19722 as ln of 9 is equal to 2.19722. As well, log of, let's say, 45 to base e is equal to 3.807. As well, you can write log of 45 to base e is equal to 3.807 as ln of 45 is equal to 3.807. So, log to base e is equal to ln. Log of x to base e is equal to ln of x. So, as well, you can write ln of 60 is equal to 4.1 as log of 60 base e is equal to 4.1. Okay, thanks for listening.